Welcome back to the Historic Mathematics Academy, an inclusive organization founded on truth, where curiosity and engagement connect philosophically to encourage lifelong learning. As always, we're glad you're here. We hope you'll enjoy today's lesson on volume and surface area with our wisest teachers, Socrates, Plato and Aristotle.
Hello again, I'm Aristotle. I'm pleased to start our new unit together on volume and surface area. This is a part of geometry. It is a branch of mathematics concerned with questions of shape, size, position, and properties of space. One of the most important aspects to volume and surface area are the units they are measured in, and you should pay close attention to them in this lesson. Surface area units are squared and volume units are cubed. Now I would like to review the volume and area formula sheet you were provided before our lesson. Let's take a moment to review this together. Notice the three columns. The first on the left provides a visual of the shapes that we will study during this unit, and the corresponding dimensions labeled with variables. From top to bottom, these shapes are a rectangular prism, which includes a cube, a triangular prism, a square-based pyramid, a trapezoidal prism, a sphere, a cylinder, and lastly at the bottom, a cone. You can then see that the two columns to the right of the shapes are their corresponding surface area and volume formulas. You will use this formula sheet as work through the various problems in this unit. Think of this formula sheet as your mathematical toolbox for calculating volume and surface area. Here are the steps to use it. First, identify the shape you are trying to analyze. Second, determine if you are calculating surface area or volume. Thirdly, select the correct formula to use. I've enjoyed speaking with you. Now I'd like for you to practice applying these formulas with my teacher, Plato.
Greetings. My name is Plato. I'm excited to teach you about volume and surface area. Let's begin with this problem, calculating the volume of this shape, with the dimensions seen here. First, let's determine what shape this is and choose the correct formula from our formula sheet. You're right, this is a rectangular prism. And the correct formula is the corresponding equation found in the volume column. Now, let's write out this formula on a clean sheet of paper, taking note of the shape and dimensions we're analyzing. I recommend that you list all the given information about this rectangular prism relating to the variables in our formula on the side of your paper, like this. Notice how I include the units of each dimension measurement. Because all of the units are the same, we can now transpose our numbers into our equation like so. Next, I want you to see how I've separated the numbers from their corresponding units, to help you understand how the solution's unit is calculated mathematically. Now you can see why the answer's volume calculation is in units of centimeters cubed, because there are three dimensions. Let's try another problem. First, let's determine what shape this is, and choose the correct formula from our formula sheet. You're right, this is a triangular prism. And the correct formula is the corresponding equation, found in the volume column. Once again, let's write out our correct formula on a clean sheet of paper, taking note of the shape and dimensions we're analyzing. Again, I recommend that you list all the given information about this triangular prism that relates to the variables in our formula, on the side of your paper, like this. Again, notice how I include the units of each dimension measurement of this shape. Because all of the units are the same, we can now transpose our numbers into our equation like so. I again separated the numbers from their units, to help you see how the solution's new unit of measurement is calculated mathematically. And now you can better understand why the answer's volume calculation is in units of cubic feet. Now, I'd like for you to continue your volume and surface area lesson with my teacher Socrates.
Hello again, my name is Socrates. I'm glad to see you again. and I'm looking forward to teaching you how to work through some volume and surface area problems. These problems require thoughtful consideration and the cardinal virtue of patience, as they are more challenging than their peer. Let's begin with this problem, seen here. Let's begin by determining what shape this is, and choosing the correct formula from our formula sheet. Can you tell me what formula is the correct one? That's right, this is a cylinder. And the correct formula is the corresponding equation, found in the volume column here, as Plato wisely instructed you to do. Next, let's write out our correct formula on a new sheet of paper, with attention to the shape and dimensions we're analyzing. Now let's organize all the given information about our cylinder that relates to the variables in our formula for volume, like this. Take notice of how I'm choosing to use the number 3.14 as pi. This is important because you could choose to use full pi instead. Full pi would technically provide a more accurate solution in your calculation. Just make sure that you indicate what numbers and units you are placing into your equation. This is important if you're explaining your work to others, as I am to you. And recall that because pi is a ratio, it is unitless as you see here. Now, because all of our dimensional units are the same, we can confidently transpose our numbers into our volume equation. Pay close attention to the radius variable. Because it is squared, both the number 5 and the unit centimeters are squared. This is important, not only because it provides the correct numerical answer, but moreover, it ensures that we have the correct units. Centimeters cubed. Good work. Now, let's try a more challenging problem. Here, we are given the volume and radius, and we are asked to calculate the height of this cylinder. Looking at your formula sheet. Can you tell me what is the correct formula to use here? That's right. We're again going to use the volume of a cylinder formula, seen here. This is because this formula has all the variables we are interested in. Volume, radius and height. Next, let's write out our correct formula on a new sheet of paper, with attention to the shape and dimensions we're analyzing. Now let's organize all the given information about this cylinder that relates to the variables in our formula for volume, like this. Notice how volume is provided in this question, but the height is not. Again, this is because we are trying to solve for the variable h. With this in mind, I believe it is wise to first rearrange your formula for volume to isolate h, as I have here. Next, pay attention to how the unit for volume is cubed, and how in the denominator the radius is squared. This is why mathematically our answer has the correct unit of meters. Which of course makes sense, because height is a one-dimensional measurement. Great work. I truly enjoyed our lesson together. Now, I would like for you to learn from my greatest student, Plato.
Hello again. I would like to now practice calculating surface area with you, starting with this problem, seen here. Referring to your formula sheet. Can you tell me what is the correct formula to use for this shape? Very good. The correct formula is the surface area for a cone equation, seen here. Notice that because the s variable, representing the distance from the tip of the cone to the edge of the base of the cone, is provided. Therefore, we do not need to calculate s using Pythagoras' theorem. Next, let's write out the formula for surface area on a new sheet of paper, with attention to the shape and dimensions we're analyzing. Let's again organize all the given information about this cylinder that relates to the variables in our formula. Now, as all of our measurement units are the same for this cone, we can confidently transpose our numerical dimensions into our equation for surface area seen here. Next, pay attention to how the radius is squared in the first term. Ensure that you not only square the number, but also the unit as well. Next, we carefully multiply and add our terms together to come to our answer, which as you can see is in meters squared. Now, let's attempt a very challenging problem that will require imagination and patience, seen here. Let's calculate the surface area of this tent. Again, using your formula sheet. Tell me what the correct formula is to calculate the surface area of this shape. Excellent work. The correct formula is the surface area for a triangular prism equation, seen here. Now, this may be a complicated looking formula, but with a little imagination, you'll see that it is much simpler than it looks. For instance, imagine unfolding the fabric of this three-dimensional tent into a two-dimensional net seen here. Notice the 5 shapes that make up the total of this fabric. And also, notice that there are 2 identical triangles and 2 identical rectangles. This is why there are 2 number 2's in this equation. Highlighted in blue. Notice here that the S variable, representing the distance from the tip of the triangular prism to the edge of the base, is not provided. Therefore, we do need to calculate the S variable using the Pythagoras theorem. Remember that because the S variable is the hypotenuse of the triangle, it is equal to half of the base squared plus height squared. Follow these calculations carefully, paying close attention to the units being squared. And to isolate the variable S, we need to square root both sides of the equation, seen here. And now, we have solved for the variable S. Having solved for S, we can now transpose all of our shapes' measurements into our surface area equation, as they all share the same units. After carefully multiplying and adding all the various terms together, as seen here, we have our answer. I had a great time practicing these math skills together. I hope to see you back here soon.
We hope you enjoyed your stay at our Historic Mathematics Academy. Thank you for your curiosity and for engaging with our math teachers. We appreciate your time. Please remember to stay safe, to get your rest, and to continue your lifelong learning. Bye for now.